In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. In example 1, you're given this situation of the special die used in the game contains 1 dot on one side, 2 dots on 2 of its sides, and 3 dots on 3 of its sides. If the die is rolled, determine the following. You're asked to find the probability of rolling 2 dots and the odds against rolling 2 dots. So as far as part A goes, let's kind of consider the dice that we have here. It's not a standard die, but these are the faces that we would see on our number cube. So 1 with 1, 2 with 2, and 3 with 3. We're looking for the probability of rolling 1 with 2 dots. Now, there's 2 dice that have two sides of the die that has 2 dots out of the 6 sides of the dice overall. So assuming that all of these have the exact same equal probability of showing up, the probability of rolling 2 dots would be 2 out of 6, which reduces down to 1/3. And therefore that would be 1/3. Now we're looking for the odds against rolling the 2 dots. I'm not considering the whole number of possible outcomes. I want to compare the outcomes of rolling 2 dots versus those that I don't roll 2 dots. So essentially, I still have 2 instances or 2 faces that have 2 dots on them. So 2 out of the 6 would, I could roll 2 dots, but 4 out of the 6 wouldn't be 2 dots. So when I want the odds against something happening, I'm going to deal with, okay, the number of instances it doesn't happen to the number of instances it does happen. So when I first write out the odds against rolling 2 dots, it's a 4-to-2 ratio because there's 4 that are not 2 dots and there are 2 that are. And of course, like a fraction, when I have this kind of symbolism here, I can simplify this to lowest terms if these do have a common factor and both are divisible by 2. So in lowest terms, this would be a 2-to-1 ratio. And that's what I would put up here. For example 2, a red marble. A bag contains 9 blue and 2 red marbles. If you select one marble from the box, determine the odds against selecting a blue marble. It went from a bag to a box for some reason. I don't know why, but doesn't matter. It's basically you have 9 blue marbles, 2 red marbles, which is a grand total of 11 marbles. Okay. The odds against selecting a blue marble. So I'm going to take the number of marbles that are not blue to the number that are blue. So in this case, I'm going to have a 2-to-9 ratio. This doesn't simplify because 2 and 9 do not have any common factors. So as a result, the final answer is 2-to-9 as well. For example 3, you're given these billiard balls and you're asked to find each ratio described in lowest terms. So if one ball is selected at random, the odds in favor of it being a ball other than the 8 ball is. Well, there's only one 8 ball. It's right here. There's 14 other balls that are not. So not the 8 ball is 14. 8 ball is only one of them. So when I want to look at the odds in favor of it being a ball other, so so being successful would be a number that's not, or a ball that's not the 8 ball. So I have 14 to 1. So I have to be careful what's it in favor of. It's in favor of not being the 8 ball. If they said the odds in favor of it being the 8 ball, that would have been a 1-to-14 ratio. Or if they said the odds against it being the 8 ball, that would again be a 14-to-1 ratio. So watch the wording because you can have a couple different wordings that mean the same thing, and you can have a wording that sounds very similar meaning something totally different. If one ball is selected at random, the odds against it containing any red coloring, solid or striped. So I look at the balls here. There's only 2 of them that had any red coloring, the 3 and the 11 ball. So the 3 and 11 balls have red, therefore there's 2 that meet that criteria, which means there's 13 that do not have any red at all. Since it's the odds against it having any red, it's going to be the number of instances where it doesn't have red to the number of instances where it does. So it's going to be a 13-to-2 ratio. If one ball is selected at random, the odds in favor of it containing 2 digits is. So I'm going to see the ones that have 2 digits to it. So 15, 14, 13, 12, 11, and 10. There's 6 balls that have 2-digit numbers on them. That means that there are 9 balls that do not have 2 digits. So it says the odds in favor of it containing 2 digits. I'm going to look for the number that have 2 digits to those that do not. So it's going to be a 6-to-9 ratio if it's in favor. If it was odds against, it'd be a 9-to-6. 6-to-9, though, these two numbers are able to be factored by 3. I mean, 3 does divide into both of these evenly, so when I do that, I get a 2-to-3 ratio, and that's in lowest terms. If one ball is selected at random, the odds in favor of it being an even number and having a solid color. So it has to both have a solid color and have an even number. So the balls that fit that category are the 2, 4, 6, and 8 ball. I have a 1, a 3, a 5, and 7, which are solid, but their numbers aren't even. And I certainly have some even numbers, but their colors are not solid. They're striped balls. So I have 4 balls with an even number and solid color, which means I have 11 that do not have an even number or a solid color. So the odds of it in favor of being an even number, so I'm looking in favor of this group here, this is what goes first. So it's going to be a 4-to-11 ratio, which does not simplify anymore. And for the last group, I mean, it's it's still looking at even number and having a solid color, but instead of being odds in favor, it says odds against. Well, I'm using the same logic here. There's still 4 balls that have an even number and solid, and there are 11 balls that do not fit into that category. Odds against means I'm going to go against even. So it's just going to basically be the reversal. It's going to be 11-to-4 instead of 4-to-11. For example 4. The odds in favor of Sam selling his motorcycle are 3-to-10. Determine the following probabilities rounded to 4 decimal places. So they're giving you the odds here in favor. So this means that if it says the odds in favor of him selling his bicycle, if there's going to be 3 chances that he will versus 10 that he won't, because it's odds in favor. So the number of instances where he'd sell his motorcycle are 3. The number of instances where he would not sell his motorcycle is 10. So essentially the probability that he will sell his motorcycle, I'm going to have this being my numerator and the sum of those two being my denominator, which means I have a 3 out of 13 chance of him selling his motorcycle. 3 divided by 13 is 0.2308. Now I could go into a lot of calculations here, but it says the probability he will not sell his motorcycle. Well, the other thing that's different is that I'm looking at the number of instances where he won't sell his motorcycle. So instead of the 3, I'm going to look at the 10. So the 10 will be on top, and the 13 will be on the bottom. And 10 divided by 13 is 0.7692. Another way I could have figured this out is to do 1 minus this number, because these are exact opposites of each other. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.